Hi everybody, today we're going to talk about properties of radicals. You guys know radicals is square roots. Some things they want to start off before we get into anything. There's these things called perfect squares. Those are numbers that you can square root. And when you square root them, they have a whole number as a final answer. So for instance, the square root of 49 is 7. If you can see right here, I listed the square roots across the top. There are obviously more of them, but those are just some of the more familiar ones that you guys see. All right, what we are going to start off with is we are going to simplify square roots. There are two main ways that people do this. You can either find the perfect squares that multiply to 48, or you can make a tree, or 24, or whatever number that you have. So we're going to start off with finding the perfect squares that multiply to 48. The easiest way is to find the highest perfect square. So for instance, 4 multiplies to 48. And I'll write that in there. 4 and 12. But you guys also know that 4 times 4 times 3, because that's 12. So that would be the square root of 4 times the square root of 4 times the square root of 3. Well, that would be 2 times square root 3. So your final answer would be 4 square root 3. Another option is you could just use it to be 16 times 3, which we know is the square root of 16 times the square root of 3, which is 4 square root 3. So that's using the perfect squares. Another option is you can make a tree. So what two numbers do you know that multiply to 48? Well, 2 goes into 48 because it's an even number, 2 and 24. So we scratch out 48 because we already used it. 2 and 12 make 24. Scratch out 24. 2 and 6, and then we could do 2 and 3. So then from there, you circle a pair. So we have a pair here, we have a pair here, and then you write the pairs on the outside. So there's one pair of 2s, so that goes there. Another pair of 2s, that goes there. And whatever does not have a pair goes underneath the square root. All right, well, what do you do in between those 2s? You write multiplication, and that would be 4 square root 3. So that's another way to look at the exact same problem and get the same answer. All right, let's try that again. 24. Which one of the perfect squares that's lying across the top multiplies to 24? That is 4 times 6. That is also the square root of 4 times the square root of 6, which is 2 square root 6. All right, the other option is we make a tree. We know 2 times 12 makes 24, which is 2 times 6. We use those up. There's a pair. That is 2 times 3. All right, these don't have pairs on the bottom. If you don't have a pair, you go underneath the square root. If you have a pair, there's one pair that goes on the outside. And final answer that way would be 2 square root 6, which is the same both ways. All right, last one for this row. You have 45. Of the perfect squares, which multiplies to 45? That would be 9 and 5. 9 is a perfect square, so you can take the square root of it. That would be 3 square root 5 as a final answer. 5 you cannot. The other option, 45, if you wrote it this way, is 5 times 9. 9 is 3 times 3. We got rid of that, got rid of that. There's your pair. The pair goes on the outside. 5 doesn't have anything, so it stays underneath the square root. All right, let's try some more. If you have square root of 25x squared, you're going to rewrite it because in between there is a multiplication. Just like we did above with like the 4 times the 12, or the 4 times 6 across the top, or the 9 times 5. If you have a multiplication underneath the square root, you can write them as their own individual square root because you can multiply those back together. So what is the square root of 25? Well, that's 5. What is the square root of x squared? That is x. And you're done. All right, move one over. That turns into the square root of 49. That turns into the square root of z to the 4th. And that is 7z squared. How did this come about? You're thinking, what two things are identical that multiply to z to the 4th? Well, that is z to the 2nd times z to the 2nd. And that is 7z squared. All right, last one. Square root of 36. What two things multiply to 36? That would be a 6. What two things are identical that multiply to x to the 6th power? That is x3 and x3. That's your final answer. All right, let's try a few more. I wrote some notes in here for us. Square root of 7 times the square root of 7. So in the notes part, if your information is underneath the square root, it can be multiplied or divided. If the information is outside the square root, it can be multiplied or divided. What you cannot do is multiply something that is outside the square root with something that is under a square root. It's just a rule, you can't do it. And we're going to talk about it in this line right here. Okay, square root of 7 and square root of 7. They're both under the square root, so we can multiply those together. That is the square root of 49. What is the square root of 49? Well, that's 7. All right, this little trick here is something that we're going to want you to pay attention to because you're going to end up using it in the next video. If you multiply something by itself, and it's in the square root form, like the square root of 2 times the square root of 2, that will be the square root of 4, which is really 2. Or the square root of 4 times the square root of 4, that is the square root of 16, which is 4. So if you notice, two of the exact same things written next to each other and you're multiplying is really just that number. Why is that the case? Because you have two of the exact same things. So you can really just write it as a square root of 7 squared, and a square root and a squared cancel each other out. So that is really that thing right there. Same thing here, square root of 2 squared. The squared cancels out the square root, so that's why it's just 2, and so on and so on. Okay, let's get back to what we were doing though. Once again, things that are underneath the square root can multiply together. Things that are outside the square root can multiply together. You cannot combine it though. So there's a 1 sitting in front of that square root 2b cubed. So 3 times 1 would be 3. The b times the 2b cubed would be 2b to the 4th. This looks like 2 times b to the 4th. This, you can't do anything with it because it's the square root of 2. But the b to the 4th, you can reduce that. So that is 3b squared times the square root of 2. All right, let's try one more. Once again, things on the outside can multiply, so that would be 6. Things underneath can multiply, but you can't combine the 2. All right, so this is the same as 6, square root of 9, square root of y to the 6th, which is 6 times 3 times, what two things give you y to the 6th? That is y to the 3, and that answer would be 18y cubed. All right, last row. When you have a square root with a fraction, you take the square root of the top, you take the square root of the bottom, and then you reduce it. So this would be the square root of 25 over the square root of 49, which is 5 over 7. Final answer. Moving one to the right, square root of 5 over the square root of 81 would be square root of 5 over 9. And lastly, the square root of 11 over the square root of d squared would be the square root of 11 over d. All right, that's all for this learning target.